Hey, we discovered an Oxford Mathematics Admission Test as per 30th of October 2019. So today we're going to consider type I question and what we have here. So we have the following equation: x times 2 to the power x equals y times 2 to the power y. So you have restriction that both x and y satisfy the following inequalities. So basically x is positive number and y is always more than x. So we need to figure out as the solution. So do we have the pair? So it means do we have x and y as the pair of numbers satisfying this equation, or we don't have any pairs at all, or we have like infinitely many pairs x and y. Let's see. So if you consider in terms of x and y simply how each expression behaves, we clearly see that if we consider as the function g from x and this function g from y, we understand that in both cases x times 2 to the power of x is strictly increasing function. So it's monotonically or uniformly increasing function. So y, let's say g is better. We mark g from x. So x is just the straight line, right? It's identity line. And 2 to the power x is an exponent. When x is 0, it's just 1, but 1 is not included due to x more than 0, so it's strictly increasing function. So that's why it goes something like this. When we multiply, so the values for the line y values is multiplied by the exponent values every time, and because they are mostly in most of the case, so the value is more than 1, so we'll get actually multiplying effect or the effect of multiplier, and the resultant curve simply represent the following. So it starts from 0, but 0 is not included, and then grows much faster due to multiplication. So that's why this is the resultant curve for the equation x times 2 to the power of x. So we can do the same for y, but in terms of the structure, it will be the same curve. However, we have always y bigger than x. If we lay out also curve from y, so basically g from y, we can say that because y is always more than x, all the values, because 0 is not included, all the values for the second curve, for the second function, g from y, which is equal y times 2 to the power y, is always bigger than corresponding value for g from x. So no matter which point you take, for example, let's say you took x equals 1, so for y, you need to have greater value than 1, let's say 1.2, very close value, but however is bigger than x. So obviously we'll have graph and g function, g value is greater than for corresponding g from x. Alright, so that's why typically you need to build up the graphs, or at least sketch, or at least just give the reason why the right side is always gets bigger than the left side when you have argument y more than argument x. So this sort of like fast track how to cope with type I question. So hope you enjoy, and just try always to visualize, and just don't strive to go and plot or just trying to create table values. So actually you can create the table values and compare, but the main and the key idea here is both functions are strictly rising with no oscillation. So that's why there is no chance when for some x and y values there will be, there will be equality. So that's why you can state the following, that x times 2 to the power of x is always less than y times y 2 to the power of y. This is always the case. Okay, so hope you enjoy and hope you understood my explanation about type I question for the Oxford test. So now we'll be trying to move next. Don't forget to subscribe. Don't forget to press the bell button to be notified about the latest updates. And see you guys.